Hello, good day to everyone. Welcome back again to our lecture series in General Mathematics. We are now in the lecture series number 10. Before I'm going to start my lecture, once again I would like to introduce myself. I'm Agi, your teacher in General Mathematics. I would like you to invite to subscribe in the channel which I'm using in my lecture. So please subscribe and click the notification bell so that should there be a lesson posted in my YouTube channel at Agipan, you will always be notified with these new lessons. Again, please watch the videos, the series of lectures, because I believe this is only uh, my way of sharing to you my little knowledge about this function or about these topics in general mathematics. What is a logarithm? A logarithm is the power to which a number must be raised in order to get some other number. Now, how do we understand this one? Let's try to consider an example or illustration. The base 10 logarithm of 100 is 2, meaning to say this is actually log of 100 to the base 2 to the base 10 is 2, because 10 raised to the power of 2 is 100, meaning to say what is that power that make a result of 100? That is the same as the 2, meaning to say this 2 is being used as the exponent of the 10 to get 100, meaning to say 10 raised to 2 will give you 100 as a result. Okay, so that is what we mean when we say logarithm. Now, how do we write this one in a logarithmic form? This is the same as log of 100 is equal to 2. When we say log of 100 is equal to 2, this is to be assumed that our base is 10. So that, as I said a while back, that base 10, which is being raised to the power of 2, will give you 100. Now, you will notice in here its illustration. 10 raised to 2 is equal to 100. This is an example of base 10 logarithm, wherein 10 is the number that is raised to a power of 2. Okay. The next one is, we have in here the statement. The base unit is the number being raised to any power. Okay. The number being raised to a power, or there are logarithms using different bases or base units, but commonly the base are 10 or a natural number. Okay, so for instance, the base 2 logarithm of 8 is 3, because 2 raised to the power of 3 equals 8. Now, how is that written in a logarithmic form? So we have in here log of 8 to the base 2, or this is read as base 2 log 8, base 2 log 8 is equal to 3. Now, you will notice that this 2 in here is actually a base, considered to be a base in the exponential form. And the 3 in here is the exponent. The result will be 8. So how is that written in the exponential form? We have in here 2 raised to 3 is equal to 8. So that is how logarithm is written. Again, when we have in here the base 2 logarithm of 8 is 3, that is written as log of 8 to the base 2, or log of 8 with a base of 2. which is equal to 3. Now, when we are going to put that one into an exponential form, that is the same as 2 raised to 3 is equal to 8. You will notice that 8 is the result. 8 is the result, which is the logarithm. Okay? Logarithm of 8. Now, another one is the exponent is 3. The exponent is 3 with a base of 2. So that would be the uh, form of logarithm. Let's move on. You will notice that a logarithm, in general, you write log, the word log followed by the base number as a subscript. Okay? The most common logarithm are base 10 logarithm and natural logarithm. They have a special notation, such as when we have this one, base 10 log, this is written using the word log. And a base 10 logarithm equation is usually written in the form log of x with the base 10 actually, okay, is equal to y. So this is actually log of x with the base 10, which is equal to y. We say this is a special notation because we do not need to write the base 10. So if we actually write this one, write the logarithm base 10, we use this form, log of x with a base 10, okay, which is equated to y, okay. So that is the simple definition or illustration of what is logarithm. Once again, our topic will be on the logarithmic function. Okay, so you will notice that when we had the discussion, or I made mention that exponential function a kind or is an inverse of a logarithmic function, meaning when we will be talking of logarithmic function, at least you should have a knowledge of the exponential function. Why? Because the exponential function is a prerequisite of the logarithmic function. So it says in here that if a function passes the horizontal line test, then the inverse of the function is considered also to be a function. You know that when a horizontal line test is used to test any function for that matter, if they are if they have an inverse function or not, meaning to say lots of function will fail to have an inverse function, or many of the function will fail to have an inverse function. So that when a function passes through the vertical line test, meaning to say it has an inverse function, meaning to say there is a one-to-one correspondence. So an exponential function, which is denoted by f of x is equal to b raised to x, has an inverse function that is a function. So an exponential function denoted by f of x equals b raised to x has an inverse that is a function. This inverse is the logarithmic function with base b. This is denoted by the expression log of x to the base b, or log base b of x, and that is how to read this function. You will notice that the next focus we will be having will be the conversion between the logarithmic and the exponential form of the expression. But before we're going to make a conversion between these two concept or two concepts, logarithmic and exponential function, there are things that we need to understand. What is this? we have in here the statement if the involved x is greater than 0 and your b is greater than 0 but not equal to 1, then the logarithmic function or we have the statement y is equal to log of x with base b if and only if your b raised to y is equal to x. You will notice that this expression in here is actually the converted exponential form of this logarithmic statement. This is read as y equals log base b of x, or y is equal to log of x to the base b, or which means that y is the exponent to which b must be raised to obtain the value of x. Okay? How do we change logarithmic statement to exponential form? Now we have in here the logarithmic form which is to be converted into exponential form. You will notice in here that the y, which is the result of log of x with base b, is our exponent in the exponential form. You will also notice in here that in the logarithmic form with our base b, now our base in here is also considered to be the base in the exponential form. Okay? Now we have in here the pattern. So you will notice the x in here is the result of raising b to the power of y. Okay? So my x in the logarithmic form is the result of raising b raising b with the power of y. Okay? And you will also notice in here that my y is the exponent in the exponential form. So this is the pattern that we will be making use when we are going to convert such exponential number. So I repeat, in our logarithmic form, we can convert this one into exponential form. Remember that our result in the logarithmic form, which is y, your y is considered to be the exponent in the exponential form. The base in the logarithm will always be the base in the exponential form. And the x in the logarithmic form will always be the result of the exponential form b raised to y. Okay? So x is the result of raising b to y power or to the power of y. Base is the base. Okay? It will always be the base of the exponential form and the logarithmic form. Your y in here is considered to be the exponent in the exponential form. So let's try to see the application of the concept we just elaborated a while back. So changing logarithm to exponential form or exponential form to logarithmic form. Okay. So you will notice that we have in here the different problem. Evaluating logarithms. Letter A. So we have in here the log of 8 with a base of 2 which is equated to 3. Now you will notice in here that considering our pattern in the logarithmic form, our 3 in here is always the y. So you will notice we have in here the pattern. I repeat, our 3 in here will always be the representation of y. And our 8 will be our x in the logarithmic form. So we have in here. Another one is our base is always the base in the logarithmic form. Now, how did we elaborate that one? As we have said, your y, which is 3, is always the exponent in the exponential form. So you have this one. So you will notice when I will convert this one, my y will be my exponent. My base will always be base, which is the base in the exponential form 2. Okay? So the result, which is that is the same as 8, is always my result in the exponential form. So the exponential form of the letter A log of 8 with a base of 2 equals 3 is always 2 raised to 3 is equal to 8. So I repeat, try to look at this, my pointer. Try to look at my pointer. 2 raised to 3 is equal to 8. 2 raised to the power of 3 is equal to 8. So that is how to do the problem. Okay, next. I have in here letter B log of the square root of 3 with a base of 3 is equal to 1/2. Again, my base is 3 in the exponential form. My base will also be 3. My my y in the logarithmic form is 1/2. It will always be my exponent. So as you can see, my y in the logarithmic form will always be an exponent. So this is my y, 1/2. It will always be an exponent. Okay? And of course, log of the square root of 3 will always be the result of the exponential function. So meaning to say, 3 raised to 1/2 is the same as the square root of 3. Okay, so that is evaluating the logarithmic form of log of the square root of 3 with a base of 3. Next, I have in here log of 1 over 25 to the base 5 is equated to negative 2. What is the exponential form of this one? Let's repeat again our form. Our 2 in here, or negative 2 in the logarithmic form, is the same as your y. And so, in the exponential form, negative 2 will always be the exponent. Okay, so you have in here 5 raised to negative 2. As I said, base is always the base, be it in the logarithm or exponential form. So, log of 1 over 25 with a base of 5 is always my base, which is 5 raised to negative 2. Now we have in here 1 over 25. Your 1 over 25 in here, which is in the form of logarithm, will always be the result in the exponential form. So I have in here uh, 1 over 25 as my logarithm exponential form, or result of 5 raised to negative 2. Now, you will notice in here, we always recall the laws of exponent, or the properties of exponent, that if any number, or any number raised to a negative number or negative exponent, will always be taken into a fractional form, and this negative will always be positive. So 5 raised to negative 2, okay, with the exponent of negative number, we get the reciprocal of this one. Okay, so what is the reciprocal of 5 raised to negative 2? That is the same as 1 over 5 raised to positive 2. The reciprocal, or the negative exponent in here will change or converted into positive. And so I have now in here a result of 1 over 25. Okay, 1 over 25. Next, what about this one? Log of 7 with a base of 7 is equal to 1. Now, We have in here its exponential form. 7 raised to 1 is equal to 7. So what is my y in here? My y in here is 1, which is in the exponential form. It will be the exponent, which is 1. What is my base? 7, which is the same as 7 in the exponential form. What is the result? Of course, log of 7, the result is 7. Now you will notice in here that any number raised to 1 will always be the number. So any number raised to 1 will always be the number. 7 raised to 1 will be 7. 6 raised to 1 will be 6. 5 raised to 1 will be 5. So that is the application of the properties of the exponent. Next, we have in here log of 1 with a base of 4 is equated to 0. So you will notice our y in the logarithmic form is 0. We have said a while back that your y will always be our exponent, okay? And our 1 in the logarithmic form is always the result. So that you will notice 4 raised to 0 is 1. In here again, we have the application of one of the properties of exponent, that any number raised to 0 will always give a result of 1. I repeat, any number raised to 0 will always be 1. Be it 1 million raised to 0, it will give you 1. 1 billion raised to 0, it will give you 1. 1 trillion raised to 0, it will give you 1. That is the property of exponent. We have to understand the basic properties of logarithm. Okay? In the basic properties of logarithm, there are things again that we have to recall. We have said a while back that when your b is greater than 0 but not equal to 1, and your x is greater than 0, and any real number y, we will be having these properties. So it says in here, log of 1, I repeat, log of 1 with a base b is equal to 0. I repeat, log of 1, which is with a base b is equal to 0, will always give you an exponential form of b raised to 0 is always 1. Okay? Another one would be log of b with the same base b will give you 1. Okay, will give you 1. Now, how is this? In the exponential form, any number raised to 1 will always be the number. Any number raised to 1 will always be the number. Okay, the next one would be log of b raised to y to the base b is the same as y. Meaning to say, when we are going to have its exponential form, b raised to y, which is the base b raised to y, is the same as the result b raised to y. So you will notice b raised to y is the result in the exponential function or exponential form. Now, our result in the logarithm is y. And so, our b base in the logarithm, which is b, must be raised to y. So, b raised to y will give you a result, which is b raised to y. Now, you will notice in here the explanation, okay? That when we have in here uh, b raised to log of x with a base b will give you a result of x. Again, if your b or any number raised to that logarithm of x with the same number, it will give you a result of x. Okay, why? Because your b in here will cancel out. Okay, your b in here and log of x with the base b, log of x with the base b will cancel with the base b just the same. So what is left is x. Okay. Another one in here is log of x with the base b is equal to itself. Log of x with the base b. Okay. Okay. So let's try to look into the application of the basic properties of logarithm. So we have in here at least three problems: evaluate or evaluating logarithmic and exponential expression. Now, what would be the result of letter A, log of 8 to the base 2? So how is that? You will notice that when we are going to evaluate this one, log of 8 to the base with a base of 2, 8 is the same as this 8 in here can be converted or can be transformed into its exponential number. Now, what would be the number or exponential numbers that will give you the same as 8? So, what is that number? That is 2 raised to 3. Meaning, 2 raised to 3 is the same as 8. That is the same as saying 2 times 2 times 2 is the same as 8. So that you will notice uh, the log of 2 raised to 3 with a base of 2, this logarithm or base of 2 now in here will cancel out, and such that this this log of 2 with the base of 2 will cancel out, and so it will give you a result, or what remains is 3. Okay, so what about if we are going to have your log of the square root of 3 with a base of 3? Now, how will we do that one, or how are we going to solve for that one? You will notice log of the square root of 3 with a base of 3. The square root of 3 in here can be transformed or converted into its exponential form. Now, what is the exponential form of the square root? That is the same as 1/2. So, the square root of 3 is the same as 3 raised to 1/2. And so you will notice log of 3 now in here, and with the base of 3 will cancel out. And so what will remain will be 1/2. Okay? So again, log of the square root of 3 with a base of 3 will be the same as log of 3 raised to 1/2 with a base of 3. Where did this 1/2 came from? This is the conversion of the radical number from fractional exponent. So meaning to say, the square root in here is the same as a fractional exponent when we are going to convert this radical number into fractional form. So what square root is the same as 1/2. So 3 raised to 1/2. Now you will notice that we have log of 3 with the same base 3. This will cancel out, and so what is left is 1/2. Now what about this problem? Letter C. 6 raised to log of 11 with a base of 6 is the same as 11. Before I end, thank you again for listening and participating in this class. May I again invite you to please subscribe and click the notification bell so that you will be notified should there be a newly posted lesson. Thank you.